I welcome you back to this New Year's edition of Formulae, Stoichiometry and Mole concept. And I wish you all a happy new year. May all your endeavors be fruitful. So we had covered item 11. So item 12 is here. A medium-sized ceramics factory uses zinc carbonate as one of the raw materials in glazing tiles. During heating, the zinc carbonate decomposes to form zinc oxide, which is useful solid material and carbon dioxide gas. The factory technician wants to estimate how many particles result from decomposition to plan material handling. In a preliminary test, they strongly heated the compound, that is zinc oxide, and 84 decimeters cubed of carbon dioxide was collected. So we are given 84 decimeters cubed of carbon dioxide. That is volume of carbon dioxide is known. What do they want? And we are also given this equation. They want determine the total number of atoms present in the amount of zinc oxide formed. So we want to determine total number. This is not, by the way, these questions are different. Determine the number of atoms present in the amount of zinc oxide. Determine number of atoms present in zinc oxide. That is different from determine the total number of atoms present in the amount of zinc oxide. So here I want to determine total number of atoms. How can we encounter this? Let me go to my response. So this is my response. So my response is here. What are we given? In this case, we are given volume of carbon dioxide. Recall that they want number of atoms present in zinc oxide. We are given volume of carbon dioxide. We shall convert this to obtain moles of carbon dioxide. Use the given equation to find moles of zinc oxide, and then we shall use moles of zinc oxide to find total number of atoms present in zinc oxide. So to convert from volume to moles, from the previous question, we have seen that here we apply the molar gas relation, which says that 1 mole of a gas occupies 22.4 decimeters cubed. That information is always given. So it is the same as saying 1 mole is equal to 22.4 decimeters cubed. We use this to move from volume to moles. So we ask ourselves, how many moles are contained in 24 decimeters cubed? And on cross multiplying, we shall have 1 times 84, then divide by 22.4. As a result, number of moles will be equal to 84 over 22.4. And in this case, we obtain 3.75 moles of carbon dioxide. Now I use moles of carbon dioxide to find moles of zinc oxide. To do that, we use the concept of reaction ratio or mole ratio. We use the given equation. So you relate what you have, which is carbon dioxide, to ratio of carbon dioxide to zinc oxide. Look at the equation for item 12 carefully. When you look at it carefully, you realize that carbon dioxide is 1 mole. There is a silent one on carbon dioxide and a silent one on zinc oxide. So the ratio is 1 to 1, implying that for 3.75 moles of carbon dioxide, since the ratio is 1 to 1, for 3.75, we shall have 1 over 1 times 3.75, and still we obtain 3.75 moles of zinc oxide. Now I have moles of zinc oxide. I use them to find number of atoms. So what do we have to note here? Note the following. We want atoms present in zinc oxide. So it is important to note that one zinc oxide like this, if you look at it carefully, it is here. It has 1 Zn, it has 1 zinc, it also has 1 oxygen. Therefore, 1 zinc oxide has 1 zinc atom and 1 oxygen atom. So we need to determine number of zinc atoms and number of oxygen atoms, then sum them to obtain total number of atoms. Ndituyinofuna atoms za zinc netugatako ne atoms za oxygen. Yeah. So the moles, we have them. We have calculated them as 3.75. So I start with the moles of zinc atoms. So 1 mole, 1 zinc oxide, 1 mole of zinc oxide has one zinc atom. That is the same as saying that 1 mole of zinc oxide is equal to 1 mole of zinc atom. Nti ku buli zinc oxide emu oyina 1 zinc. 1 mole of zinc oxide has 1 zinc atom. Therefore, what of the 3.75? If one has 1, therefore 3.75 will also be having 3.75 moles of zinc oxide. Yes. So I have moles of zinc atoms. Sorry, moles of zinc atoms. So if 1 mole of zinc oxide has 1 mole of zinc atoms, then 3.75 moles of zinc oxide will equal to 1 times 3.75 moles of zinc atoms, and this will still be 3.75 moles of zinc atoms. Now, these are not the atoms. If you recall from the previous discussions, if you are watching this video for the first time, I'll refer you to the previous sessions. These are just moles of zinc atoms. They are not number of zinc atoms. So to find number of zinc atoms, we use the Avogadro's relation, which says that 1 mole of zinc atoms is equal to 6.02 times 10 power 23 atoms. So if one has these atoms, what of the 3.75 moles? This will have 3.75 times 6.02 times 10 power 23 atoms. And computing that, we obtain 2.26 times 10 power 24 atoms of zinc. So these are atoms of zinc. Then I determine atoms of oxygen. Still, we know this now, that 1 zinc oxide has 1 zinc atom. So we have seen for zinc. Now we are interested in oxygen atom. So moles of zinc, they are still 3.75 moles. And 1 mole of zinc oxide has 1 mole of oxygen atoms. Therefore, if one has 3.75 will be having 1 times 3.75 moles of oxygen atoms. And in this case, we obtain 3.75 moles of oxygen atoms. So these are moles of oxygen atoms. I'll tell you that these are not atoms of oxygen, they are moles. So to find the actual atoms, we use the Avogadro's relation, which says that 1 mole of oxygen atoms is equal to 6.02 times 10 power 23 atoms. What of the 3.75 moles? This will equal to 3.75 times 6.02 times 10 power 23 atoms. So we obtain the same number of atoms. What do we realize? So if you are a learner who easily recognizes things, you've seen that zinc oxide has 1 zinc atom. It also has 1 oxygen atom. So this may not be necessary. Let me hope we are clear. If you realize that zinc is 1, oxygen is also 1 atom, so you only calculate the number of atoms of zinc. If you calculate the number of atoms of zinc only, then you have it in mind that since oxygen was also 1 atom, the number of atoms will be equal. That since it is 1 zinc atom and 1 oxygen atom, a serious learner can simply calculate for zinc, then for oxygen, they will be the same since they are 1 to 1. So then the total number of atoms, we add we add those of zinc plus those of oxygen, and summing these two, which we've obtained, we obtain 4.52 times 10 power 24 atoms are present in zinc oxide. Allow me stop here. So I've attempted all the items. The 12 items. Next we shall look at empirical formula and molecular formula. Items on those concepts, molecular formula and empirical formula. Yeah. As of now, allow me stop here and wish you a happy new year 2026. Enjoy the vibe.